Hello, my name is Ryan Sulit, and this is my submission for COMP0035 Systems Engineering. And this is my individual coursework showing video demonstration showing that I have a working development environment. So what's on the screen right now is the GitHub repository that Group 13 or my group members and I have created in order to store our changes and basically just have a directory for our source code every single time that we update our code. Ideally, it will update to this repository. So as you can see, our current files are right here and various edits have been made. I'm going to show you that I'm going to show now my working integrated development environment. And the IDE that I'm working with is PyCharm Professional. So the purpose of an IDE is it serves as the environment in which we can actually code and program the actual software that we would ideally have, as well as test that code, and later on, should we choose to deploy that code. So this right here is the opened cloned project, or the local version of the group repository, the GitHub repository they currently have. But just to show that it is a clone project, I'm just going to reopen it again right here. All right, so this right here is the clone project into my GitHub repository. So what's shown right here is the user account Python file, and this is essentially the Python file that I have created to demonstrate that I have a working understanding of what a Python class is. So it's made up of attributes as well as methods right here, and as you can see later on, this is the method that I'm going to be showing for the unit test. But for now, in order to demonstrate that I can make changes within my IDE and then push the changes to the GitHub repository, I'm just going to quickly add a comment saying that this is my work. So putting my name and my student number. So having made the changes that I want to make, I want to go and commit these changes. So I'm just going to say that I have added comment or added name sn to file. So I'm satisfied with that commit message, and I'm going to commit it and push. So this right here right now, this is the change that is going to be made and pushed to the actual master branch within the GitHub shared repository, and this is the actual commit message that I'm adding, and I'm going to choose to push it. After having done that, just waiting. All right, so this notification tells me that it's pushed to commit to the master. I'm going to just now pull just to make sure that I've updated all of my files. All the files are up to date, and yeah, I'm just going to again update the project again. All right, so all the files up to date. So now if I go back to the GitHub repository, this is the GitHub repository that hasn't been updated yet, but if I refresh this repository, it should show that, yep, right here. So the Python class, or the Python file that I made the change in, which is a user account, it has seen that 1 minute ago I did make the change from my IDE, and if I click onto this change, as you can see right here, it's detected the actual change that I've made, which is just simply adding these two comments that I have added my name to it. So yeah, so that demonstrates clearly that I can make changes within my IDE onto my changes to my local files on my IDE, and once I push those changes to the GitHub repository, it updates the source code within this directory for everyone else to be able to see. I'm now going to be demonstrating the unit tests and the test class Python file that I've created. So this is the original Python file, and given that this file right here is called test user account py, and this is the test Python file in which I've created in order to test some of the methods in this user account. So right now the class hasn't been fully implemented yet, but what I have created right here is one simple method that simply takes in or sets a new location for the user account. So what it does is whenever this method is called, it updates the global variable of set location to whatever the new input is when this method is called. It prints onto the console that the location has been changed to the given input before again returning the set location just in case this method is called once again. So going to the actual unit test file. So this test file contains a class called a test user account, and what it simply does is it creates a test user account in which we can actually test these changes that are being made. And so it has this setup method, this main unit test that I'm going to be demonstrating today, as well as an additional unit test just to demonstrate something else. So the setup right here, the way it works is it first creates a test user account before setting an initial test location for the class. In this situation, I've set the test location to be London. The main unit test shown here is a test edit location method. And what it does, it sets a new test location. In this situation, it's Manchester. And then it calls the edit location method right here and changes it to whatever this test location is. So it calls the edit location method in the user account class and sets it to Manchester, and then stores it into this new local variable for this method called location check. Last but not least, the actual test right here is this assertion command that simply checks if the original location that was set, the new test location set right here, is the same as the test location is the same as the location that was returned by the new edit location method after it's been called. And as you can see right here, if I actually go press and run this unit test and demonstrate within the results right here, it has run without any issue. Test has been passed. And as you can see right here, it has printed onto the console that the location has been changed to Manchester, and this is from the print command within the original method in the user account file. So that has been successful. I'm also going to demonstrate that failures or failed assertions can also be purposely made. So in right here, it's a new unit test, and it essentially checks that the expected location is Manchester, and it checks the expected location versus the currently set location of the actual user account class. So if I actually run this again, to run this particular test, as you can see here, the assertion has failed, and this is what we expected to fail, meaning it's been successful because the user account, since it was originally set to London, it's London right here, and it's clearly different from the expected location of Manchester, which is set right here. Because Manchester and London are different, it returned with a failure. I can also demonstrate that that not only can I run individual unit tests, but I can run the entire Python test file itself. So if I go quickly into my local console and just open up this file, it says that I've run 2 tests and 1 failure, which is again expected. The first test, location change to Manchester, has been successful, meaning that the original assertion of checking the change location of Manchester and the actual return from the method is successful. And this is the failed test again, as shown earlier, checking that Manchester is not in fact London. So that demonstrates that I've written and performed a unit test, and that I can view the results within my IDE. Last but not least is showing the database in which I've created based on my group project's schema. So quickly demonstrating what my group project schema is right here. So this is the schema that has been created by my group. And as you can see right here, there is a lesson review, lesson, learner, forum post, Langcoin wallet, teacher, and bank account tables. And it contains all the necessarily like columns within the tables, as well as showing the relationships between these entities through the use of primary keys and foreign keys. So the way I'm going to be demonstrating my database is using phpMyAdmin. So a I created a MySQL database using phpAdmin, and I've exported the SQL, but I can just quickly demonstrate that it works. So I'm going to create a new database for this, and I've successfully created right here, and I'm going to go and upload my SQL file the MySQL file that I created, and there you go. So as demonstrated earlier in the schema, I have these 7 tables which contain all of the necessary columns that has been specified within the schema itself. I can go to any one of these and it contains the actual tables. It does not contain sample data as of now, but considering that is not required, no sample data has been set. So this reflects the database design perhaps best if I go to the designer or to looking at the relationships. So as you can see right here, not only have the necessary columns within the tables been set, but also the relationships based on the primary key and foreign keys has also been created right here. So if I just quickly organize this in a more understandable way, apologies for this. So yeah, so right here. So this demonstrates that I've shown the relationships between the entities through the primary and foreign keys. For example, such as the learner key has its own primary key right here, and various other tables that use the learner ID as a foreign key include the lesson review whenever a learner makes a lesson review, a forum post whenever the forum post gathers information of the user who actually posted the forum, in this case a learner, as well as the interactions that the learner has with the Langcoin wallet and the bank account. Vice versa is the same for the teacher interacting with the lesson and the Langcoin wallet. And yeah, this concludes my video demonstration of my working environment in which I can develop and test my application, as well as showing my SQL file that I've created for the database. Thank you very much for watching.